We're now going to get to what is the core or foundation of supervised machine learning, and that is training data, which is what we have here. Before getting to this, though, I want to make a few comments about unsupervised machine learning. First, recall with unsupervised machine learning, we were asking the algorithm to go into the data and find patterns and insights for us. We don't know what's in it. With supervised, we do know what the data is, and because we know it, we're going to teach the algorithm about that data. That's why it's supervised. The second thing about unsupervised machine learning is that often it can be used to help us learn more about the data to help us then create training data sets like we have here. This particular type of training data is called tabular. It's nothing more than a spreadsheet or relational database. There are other kinds for like unstructured data. In the case of document classification, where we're using other methods of training on documents. For example, document clustering that helps us then establish what classifications documents should be in. But that's beyond the scope of this video. This is a silly kind of example. I did mention we were using day-to-day examples. This is dogs and cats, but I think this actually works very nicely for our purposes. The two terms that you want to be familiar with here is on the far right we have what's called the label or the class. This is classification, so these are classes, and these classes are going to help us make future classifications of dogs and cats, which we'll see in a minute. So this is the classification. The class is here. There's two. It's a binary classifier, by meaning two, dog and cat. These other columns, excuse me, are called features. And these features are going to be used by the supervised machine learning algorithm to help it learn about the data. And essentially what it does is it's going to take all of the all the rows that have this dog in the far right hand side and try to learn what makes a dog a dog. It's going to look for patterns, consistencies that make a dog a dog. It will also then look at this other class called a cat, look at all of those rows and try to determine patterns and consistencies that make a cat a cat. Its goal is to try to find a way to tell the difference between a dog and a cat, so that if we remove this set of answers here and then ask the algorithm to go predict, that it can do so. So for example, what it will do here is we take away the answer and we then say, all right, you've learned enough, you tell me what was here before. And then what it will do is it will do just that. It will of course make mistakes. Here's a mistake we don't know about. This one I will explain in a minute why it got this wrong, but this is called its accuracy. And how well it performs depends on various things, but really the goal was to have data that helps us to distinguish between cat and dog. A couple of other terms I think would be helpful to know, and terms I will use in explainability when we get to our explainability series in Shapley values. I will refer back to this video. So I'm going to call you out on that here to let you know that that's coming. There's a thing called dimensionality reduction, which involves feature selection, which I'll get to in a minute, or just the removal of things we know without saying anything more are useless. Number of ears is a useless column because all cats and dogs have 2 ears unless there's been an injury. So this is useless. It doesn't help us determine the difference between cat and dog. However, this column here has to do with eyebrow muscles. Only dogs have eyebrow muscles. These are the things that help dogs kind of mimic human emotion, because their eyebrow muscles can move up and down and frown and rise up and stuff and mimic humans. Cats don't have them. So all you really need in this spreadsheet is this column alone. If it's a yes, it's a dog. If it's a no, it's a cat. We can get rid of everything else. So we rarely have the luxury of this type of information. So first we remove, in dimensionality reduction, we remove columns we know are useless, like tail, same thing. But the rest of this we don't know. So let's just take out the eyebrows for now and just work with skull shape, leg length, and hair length after having removed these two. There's a thing called feature selection. And what the algorithm will do is it will take this file and remove a feature like hair length, which is completely remove it. And then it will run the algorithm again and see if the prediction changes. If it doesn't get any better, then this was likely not a useful feature to have in the prediction. Maybe it was. It goes through and does this iteratively with all of the features. It removes them. It may remove 2. It may remove 1. Often you'll have dozens of features. It may remove 5 or 10. It just goes through this iterative process until it has the least number of features that it needs to keep the same level of prediction. It might even choose to lose a little prediction accuracy if it thinks it's worth it. Of course, you will want to have somebody who understands the topic to make sure that removal of something doesn't have some other impact. So that's very important. The other thing to consider here, though, is also one of the banes of training data is missing values. Here, this was unknown. So I think that's what threw off the prediction here. Again, I made this up, but that is ostensibly in our example here what happened. So replacing this information is another data science task, which is beyond the scope of this video. The other thing I want to note here is that you can have, of course, more than 2 classes. You can have dozens or hundreds. In the case of compliance, this could be fraud or non-fraud. You would have patterns indicative of those, or threat or non-threat. Or maybe you have level of risk. You could have low, medium, and high, or you could have numeric indications of risk, 1 through 10 or 1 through 5. So the number of classes really is up to the application, and assuming that the data is going to be sufficient for this machine learning algorithm to make decisions from. It's also possible that it's more than just a single column. You might have aggregated data in the way of log files or other information from which you can then build classes and establish threats so that that information then can be used to make predictions in the real world.